Excuse the mess. After a lengthy interval in this project, I am resuming my work on my homebrew 40 meter band single sideband radio. Now, what we had before my break was my direct conversion receiver. I was able to test it on air and get some Morse code. Here's some Morse code, just using a very poor antenna. So that gave me confidence that the receiver was working. Now what I'd like to do, which is the crystal filter. So I'm actually working on the crystal filter right now, even though I'd like to build up just a double sideband transmitter initially. And what I've done is I've built up a little oscillator here to test my crystals. So Charlie Morris described the process he used. He just did a 4-pole filter, and he basically just picked a bunch of crystals that were very close in frequency, and he used SDR, like an RTL SDR dongle, to sniff an oscillator with the crystal in it. So here I've got a crystal. It's actually powered up at the moment. And then I have what's called a, I'm going to forget the name of it. It's a Colpitts oscillator, right? Yeah, and I'll link the paper that I read on the circuit to use. Charlie Morris had a very simple circuit which used one of these 547s transistors. I didn't have any luck with those, and I didn't have any luck with his very simple oscillator. I had to do something a lot more elaborate to get an oscillator working. So I ended up with a Colpitts. So it's got 2 transistors in here, but it's still a very simple circuit. I actually had to make some modifications to the initial oscillator, and it's working well. I'm just got a 3-volt supply here, and there's a power switch, and just some resistors and capacitors there. And I'm just sniffing that using my SDR and just a little inductive loop here on the end of a coax. So I'll show you what I got here. Alright, here's the oscillator powered up. We're looking at a crystal here, and this is SDR sharp. What I found helpful, okay, obviously I'm already zoomed in quite far here. This is a 10 megahertz crystal, and you can see the resonance fairly obvious at 10 megahertz. I'm able to pick this out as actually being my oscillator by obviously just powering it on and off. I can verify, or actually just pulling the crystal is a simpler way to do it. If I pull the crystal, that disappears. So there are the crystals out, and if I put it back in, that should come back. There we go. Because you get stuff like this over here. You can see that there's a peak, and there's peaks over here. So to know what, clearly what is your oscillator and what's just other garbage, you can just power it on and off or pull the crystal. So anyway, if I zoom right on in here, you can get pretty good idea of where we're resonating at. So so there we go. We are at, and we can actually just go by increments of 1 hertz. There we go, 9.997357. And if we pull that crystal and plug in the other one, I've got a whole bunch of these crystals, by the way. I got them for really cheap off of eBay. A bunch of 10 megahertz crystals. There we go. You can see we're off to this side now. So let's scroll over there. There. 9.997493 megahertz. So yeah, I'm going to find a bunch of those crystals that are close in frequency and build my crystal oscillator, crystal filter with those crystals, and that'll be a separate video. I wanted to discuss the oscillator because apparently getting back to basics is what I find difficult, and I'm sure I'm not alone. So I'll show you the schematic that I used and give you the link for that, and good luck. Alright, so here's the schematic that I worked off of. So this is a Colpitts oscillator. I think it's called actually a buffered Colpitts oscillator. So you've got your crystal here. Here it shows a switch to ground because they're talking about a method for characterizing the crystals. I just wanted to know the resonant frequency, and this goes straight to ground here. There's where I plug the crystal in, so I've got a header there, so I can plug it in, or a socket, I guess you could say. A couple 10K resistors to divide the voltage going to the base. I don't have a 47 ohm resistor here. This is actually just a 3-volt battery that connects right to this power rail here. I do have a filter cap, 100 nanofarad, 2N4401, a pair of those. I did use that transistor. Like I said, I was working with the BC547 before, but it wasn't working for me. And yeah, 470 picofarads. 2 of them, and then a center or a tap between them to the emitter here, 1K, 1K, 1K. So anyway, I found this worked well.